Okay, climbing. How do we do this? Well, I'm going to explain the theory for you here in two-dimensional terms, and then we'll move into Godot and we'll do it in practice. So, this is the player, and he has a ray on his chest and a ray on his head. As the player moves through the world, we want to check if this chest ray, which is going to be quite a bit shorter than I made it here, but I made it longer just for ease of readability. But yeah, we're going to check if this chest ray is colliding with a piece of the environment, so a solid wall or something they can climb over. When this is colliding with a piece of the environment, we're then going to check this second ray here. Is this not colliding with anything? Because we're using this ray 2 to check, okay, is there somewhere for me to actually climb up here? Now, if this returns false, then no, we don't climb. But if you can imagine the player jumps up and they're holding space, we then go, right, okay, this, if I wand this is now not colliding. So our two conditions have been met. We tell the player they can climb, and up and over the wall we go. Hope that made sense. We're now going to go and do it practically in code. Okay, so here we are, and I'm going to just explain briefly how we put this together in practice. So if we go down here, you can see we have a bunch of rays. We actually have 6 rays for the head, not 1, and I'll explain why that is shortly. But first of all, we have our chest ray here, and you can see it starts at the center of the character controller and extends out just a little. So the radius of my capsule here for my character collision shape is 0.5, I believe. So it's 0.6 here, so that'll be 100 mil. So yeah, you want it to stick out just a little bit. Your head rays, on the other hand, are a bit more complicated. What we do with these is we ensure not just that there is an open space in front of us that can fit our collision shape, but we want to make sure that there's enough space vertically as well for us to move through it. And that's what these ones that are pointing up here do. So if you look at one of these, you can see they have a cast 2 height of 2.1. So what they're doing is basically making sure that this, again, collision shape here, which is 2 meters tall, has enough and then a little bit more room to move, because we don't want any situation where we're getting stuck on any of the geometry. Okay, so here in the player script, we can start going over how this works. The nodes involved, which we have references to here, these here, the chest ray and the head rays, the parent node of the parent node of the head rays here, this one, and the tween here, which we'll use later. So if we go into the process function here, you can see this is how the climbing works currently. I'm going to delete this because I'm going to do it better, and I'm going to add here and can climb, which is a function we're going to define now. So let's go down here, func can climb. First thing we're going to check is if the chest is colliding. So if not chest ray dot is colliding, turn false. The next thing we're going to check for is if the head is colliding. So if that would be head rays dot get children, and I'm going to do this wrong here just to demonstrate something. So I'm going to get the first reference, or the first index is colliding. Then we're going to return false. And if neither of these return false, we're going to return true. So what this should now do is, if I actually have to go back up and put something back in, character mover.climb ledge. And I'll explain this in a moment, so don't worry. So let's run this. Okay, here we go. Turn around, we run at this, jump, And yeah, it pulls us up over the edge. That's what we want. Now let me demonstrate an issue here. And I'm actually going to turn off my collision shapes here. Yeah, let's demonstrate an issue. Right, I need to go in here, duplicate this block, move it up to about there. And let's see what happens. Because you'll probably guess what's going to happen. It's going to do some weirdness. So if we turn around and we run at this, oh goody, I am now trapped in a piece of geometry, and I can't get out no matter what I do. Yeah, so that's bad. So let's explain why this is happening. If we only check with one ray, so if we only check with this first ray here, we have no understanding of what's above us, right? So that's why instead of doing this, we do for ray in head rays dot get children. And we check if ray dot is colliding. And if it is, we return false and we stop immediately. So if we go back in, you'll now see. There we go. You'll now see that we can't cause that issue anymore. It's stopping us. So, yeah, that's basically it for getting it to work in a manner that won't cause bugs. Oh, I'll actually mention one more thing. The reason we have 6 of these, so if we look straight down, and if I go into orthogonal view here, well, you can see that the rays are basically lining up perfectly with the width of the collision shape. So that makes sure that there's physically enough space to fit from side to side. And yeah, that's all there is for that part of it, at least. So if we go back in and we go to, I think we need to go back to process, and where is it? There it is, climb ledge. So climb ledge. Ah, I've actually said this wrong. This needs to be grab ledge. So, what we do here is, in grab ledge, we first set our velocity to 0. We do this because we don't want any leftover velocity at the end of our climb. I had a bug for a while where we would have velocity at the end, but the player had jumped up to climb over the wall, right? So when the tween that moves the player ended, they would still have some vertical velocity left, so they would do this weird little hop at the end. So yeah, we zero the velocity to make sure that that sort of thing can't happen. Then we disable swimming, which is something I do for my character controller because I can swim. If you want to know how to swim, I have a video on that. I will link to it at the end and in the description. We then set our state to hanging so that we have a separate state for this part of the player's movement from everything else. Just trust me, state machines for movement make everything a lot nicer. We then climb the ledge. Now, climb ledge, we first check if we're already climbing, because we don't want to check this multiple times. It'll introduce bugs. Or, sorry, we don't want to execute this multiple times. So, here, we set that to true, so we can't do it more than once. And then we actually call our climb function, which is this body to move, in this instance, is the player. So, if we go back into the player, which brings us here, and we go down to climb. So this is all powered by tweens. I'm going to expand this out. Yeah, this is all powered by tweens. So you can imagine the movement here as sort of like a right angle. So the player moves up by 1.85 vertically, and then they move forward by a little bit, by this amount down here, which I can't remember exactly what this is, but it's not much. I think it's like 0.3 meters or something. So the first thing we do is we turn off the ability to jump, and then we freeze the ability to move the camera, because if you move the camera around while you're climbing, it looks really strange. So yeah, I turned that off. These here just define how long this tween takes. And these two at the bottom here, these are just me messing with the camera to make it look like the player is climbing. You don't have to do this, so I'll actually comment those out for the moment. That one and that one. These are the ones that actually matter here, the first ones. So what we do is we're interpolating the player's origin, and we're moving them on the Y value by this amount here. So what we do is we first get our position in the world, and we add 1.85 to our Y value. And this determines here our new vertical movement. We do that in vMove time, and then we have some easing here just to make it look a bit nicer. So we start that tween, and then we wait for it to finish. Once it's done, we know that we're up to the right height, and now we're going to move the player forward. And we do that by getting basically our forward vector, the negative of it, and then we multiply it by 1.2, which gives it the positive value, and then we add that to our origin, which gives us a point a bit in front of us. We then start that tween here. We start here, yeah. We wait for it to finish, and then we call our ledge climb completed function. We make it so we can jump again, and we make it so we can move our camera again. If we look at this function real quick, all this does is it sets our called climb back to false, so we can climb again if we want to. We turn our swimming back on, and we set our state back to idle. Yeah, and well, that's pretty much it. So if you have any questions, then of course feel free to say so in the comments, and I'll do my best to get back to you. If you want to know how to swim like this, there should be a video on screen now for you, and yeah, see you next time.